Okay, so in the previous example, we had waves being pushed by sort of northerly winds onto the shore, and we looked at sort of wave patterns associated with a parallel shore structure, coastal armoring structure. Now, in this example, we see that the wind is pushing waves in towards more of a northeast direction. So how is this going to affect sort of wave energy as it breaks on the coast, and also the movement of material on the coastline?
Right, like you said. So in this case, we don't have the waves approaching the shore perpendicular exactly.
Right.
And so if I drew, say, something like the velocity vector here, something like this.
Right.
Well, we can take that vector and we can resolve its components. And so it has components something like this.
Mm-hmm.
So it has a component up and a component to the east here.
Mm-hmm.
And so ultimately what that's doing, these waves are carrying sediment, sand with them.
Mm-hmm.
And so as these waves approach the shore, they're going to reflect off. They're going to hit it. They're going to reflect off.
Mm-hmm.
But still, waves are coming in. So they kind of bounce around like this. And so we get this kind of bouncing looking pattern right off the shore in terms of sand being transported.
Yeah, because as you mentioned, part of this vector component that's pushing wave energy and sand towards the shore, part of that is moving to the east. So overall, we see that there's going to be a net movement of material along the shore face or along this east component of motion. So this is called longshore drift. And that just basically means that material is drifting along the shore because of this prevailing wind direction that pushes material. Now in this case it's being pushed to the east, but if your prevailing wind was coming, say, towards the shore at a northwest direction, you would see a net movement of material to the west.
Okay, that makes sense.
So this process of longshore drift pushes sand along the coastline. But some coastal communities don't necessarily want sand, right, to come into, say, their local harbors or their ports, right, because then it tends to build up and maybe it causes issues for ship traffic. So what these communities will do was that they will emplace a coastal armoring structure called a jetty. So I'll draw in a jetty here and the paired jetty wall here.
And this looks different from the last exercise in that the orientation of this structure is now perpendicular to the coastline.
Right, so now we have a shore perpendicular structure. And these structures, sometimes they're completely underwater, sometimes they extend above the water. I think the more common examples are they're underwater structures, so you might not even know that they exist. But you can tell that they exist because of a net effect that they'll have on sediment movement. So your example of longshore drift was that sand is going to move along this coastline, right? But the emplacement of this structure underwater means that this sand basically gets trapped along this jetty wall. So over time, you'll see a buildup of sand, maybe in a fashion something like this. Okay, so the sand is moving along the shore, it hits this wall, and it can't go any further. So it gets trapped, and over time the sand builds up and eventually starts building out the beach, say the beach along City B in this case. Okay, but if we look to the other side of the jetty, what's going to happen to City D over time?
Yeah, it seems something's going to happen because some of the sand maybe is not getting to City D.
Right. Before this jetty was in place, the sand could move all the way to City D. But now we've placed this barrier. The sand can't get to City D. But we know that we still have wave energy hitting this shoreline. So we could draw exactly what you drew over here around City A and City B here in City D. So we have the waves coming in. So we have a net movement of sand, just as you drew. But now this material is being pushed along the shoreline. So over time, all of this material is going to leave, right, and be pushed towards the east. And so we see erosion occurring at City D. So I'll draw that as these lines here. So the sand that was on this beach before the jetty was in place now is pushed away, and the coastline starts to erode back.
Okay.